Yeah. All right. Thanks. So what that bio means, I'm older than dirt. I started in CPM. Raise of hands. Who knows what that is? Oh, God. How many know what MS-DOS is? Guess what? That was CPM before it was bought by Bill Gates, and I'm bad on names, but that's where it is. That'll give you an idea. So yeah, I'm older than dirt. Obviously military background, the whole 9 yards and everything. But I want to see what we got in the crowd here first. I'm very opinionated. Don't hold that against you. Anything I say that might offend someone is purely by accident and everything. Got to get those disclaimers out. So how many are programmers here? Okay. How many want to be programmers here? All right. How many consider themselves front-end web developers? All right. All right. How many are back-end developers? Raise your hand if you don't know what a back-end developer is. I'm really trying to judge the crowd here. So anybody here worked at the enterprise level? All right. Anyone here doesn't know what the enterprise level is? All right. I'm going to try and cover all that. How many here know what a strong type language is? How many here know a strong type language? All right. How many here know interpreted languages? All right, cool. So that just gives me an idea, but that's kind of some of what we're going to cover here. So before I get too far into this, let me get organized. Those are the screen controls. So I'm going to go down this rabbit hole first before we get to the presentation. Meetings being recorded. Okay. All right. And Control Alternate Shift H to hide those controls. So all you Python people, raise your hand. So if I was going to learn Python, I mean, I did the classes, I know the basics, but I haven't done any real work in it. But if I was going to do that, I would do what I did to learn JavaScript years ago. I opened up jQuery's files. Hey, it's there to read. You just get the unminified version and start reading it, and you can figure out JavaScript and some of the right ways to do JavaScript and some of the bad ways to do it. Likewise, this is called searching or CRXNG, whatever you want to call it. I didn't write it. I just stand it up because I have a background in cybersecurity. I have a home lab at home, and this is running in my home lab. And I have it open to the public, mainly for myself to use, so that when I'm in the office at work, I do all my searches through this. It's a search engine aggregator. Depending on how you select things, and I encourage you to go look for this product. Source code's on the bottom. It's in Python. If I was going to learn Python, that's where I'd start reading. Because if you think about it, this thing goes out. If you do a search, the language I'm learning now, not for work, just for fun, is Rust. That's what I'm doing for fun. Enjoy life, right? So what is Rust? Well, it's a programming language. Well, that's pretty cool. Let me shrink this down a little here. So it's a search engine aggregator. What this did was it went out to all the search engines I have selected in this little section of preferences, and it sent my search request to Bing, Google, Quant, all these places. And every time it sent it out, it didn't send it out as Ron Garlic. It sent it out as whatever made up name it came up with. Meaning the search engines can't track who you are. So you're not getting a tailored search. Think about that. So if you're going to that search engine for the first time, what happens? And this is a rabbit hole I'm going down from the presentation. What happens is it's going to come back with just the plain, unadulterated search tailored for you. Every time I do a search with this search engine, 1 and 2 is always where my answer is at, for the most part. It can break down by categories like IT, whatever. That's what I have it set up for. And the point is, it anonymizes it. Nobody's determining who or what John Smith or Jane Doe is searching for. It can't keep track of you. So that's the advantage of this. If I wanted to search something that I didn't want the FBI to know, it would anonymize it. They couldn't trace it back. They could trace it back to the main IP, but it wouldn't necessarily mean it was me. Okay. But other than that, it's that kind of thing. So if you want to learn Python, I would recommend going, let me go to here. So at the bottom, you see public instances. Let's right click on that bad boy. And these are public instances. There's companies and all kind of cool stuff there. You can find one of these rather than mine and use that as your search engine. And everyone's got the interface a little tailored, because on mine, you'll see I have it set up for everything. Low system resources may affect your audio quality. Okay. So when I do search something there, Rust, well, we're not going back to that. You saw it. And that's not what we're here for. You see the source code on the bottom. You can see engine stats. Of course, this is until I have it set to automatically reboot, so it clears the stats. But from this here, you can see what your faster search engines are. When it gets searches went out across all of these, and it rates them. Believe it or not, Bing is proving to be way faster than Google, by the way. Every time I look at this, at least for the searches I do. So that's just the nicety. I have a home app I mentioned at home. I have a firewall in front of it. I have proxies, all kind of good stuff like that. I have a Red Hat developer license. I have a Red Hat developer license. And you too could have a Red Hat developer license. That'll get you 16 Red Hat servers at no licensing fee or anything, and all the development you can do, which kind of segues back into what we're doing here, full stack development. All right, before I get to the meat of it, the code and everything, I'm going to get back on track here. Let's see, yes. It says do slide deck here. All right, before we get to the code. So full stack development, that's me. Our agenda for tonight is I've worked at, we can talk about that later. I've been everywhere, blah, blah, blah. And then I'm going to tell you a little story here. Got a few slides for that. We're going to wrap up the slides, and then we're going to get into the code, which is what most of you are here for. So let's do that. That's my disclaimer. You know, anything with the story, anything I may say, let's consider it fictional. Didn't relate to a person living or dead, though it might be related to the Three Little Pigs. I'm not sure, but whatever. So we'll go there. So let me tell you a story first. Now, keep in mind, I got a lot of security stuff in my head. I'm going to tell you the story of the Three Little Programmers. Now, the reason I went to the search engine, I didn't do what I wanted to do, because if you look here in the bustling tech city, we'll call it Fort Myers, there were three little programmers. One was named Sam, one was named Alex, and the other was named Catherine. Now, Catherine, yes, Catherine Zarella, Catherine Johnson of NASA fame. Okay, and I was going to look her up in the search engine, which is search.garlic.net. If it happens to be down, it's because I'm playing around with it. But you could try that out even on your phones. So each of them set out to build their own application. All right. But their approaches and their skill levels were greatly different. So here, let me dive into the story. Just keep in mind that our hacker, I'm going to refer to as the big bad wolf. So Sam decides he's going to build his straw house application. It's an application on how to build a straw house. He's a novice programmer. Got to start somewhere, I did. And he was eager to launch that first web app. We all like those web apps. That's where we start. Not in my day, you didn't start there, but nowadays that's where everybody starts. He was really enthusiastic at the idea of front-end development. He was going to make himself a lot of money. So he focused on creating a visually appealing interface with basic HTML, CSS, and a bit of JavaScript. He was cool. Showed that to his mother or whoever, and mommy was happy. So was daddy too, because he got a job to build this app. Kid's making money already, and he's still in high school. At least that's where my nephew was. And his family cannot convince him to go to college, and he just got a gig, sidetrack, for about $140,000 a year. And well, I gave him half of my equipment when I moved down here, so you can guess what the influence was there. So I'm in trouble for him not going to college. So the application looked really good. It was sleek and modern, almost as pretty as what Zarella can make. But Sam was unaware of the dangers lurking in the cyber world. So briefly, his construction, you can see what it is, was just HTML, so on, so on, so on. So Sam built the application quickly, but it lacked fundamental security practices. Raise your hands. You know what those security practices are? I see 1, 2, 3 hands there, maybe 4. Come on, Vicente, I knew you'd know. And Marcos in the background. Is Marcos online? He said he was going to be. At any rate, he knows too. So it lacked, there was no error handling, no data validation. There was no protection against any common attacks like SQL injection or cross-site scripting. Okay. It was a house made of straw, fragile, very easy to penetrate, probably leaked like a sieve. Then one day the wolf strikes. A hacker came across Sam's application. He goes, aha, with little effort, the hacker exploited all kinds of vulnerabilities, injecting malicious scripts, trashing the database, got access to the unauthorized access to the back end, moved money around, all kinds of stuff. So the straw house collapsed. It left Sam with a hard lesson to learn about the importance of security. So he went running to his cousin, Alex. Alex was a little older, a little more wiser and experienced. He was an experienced programmer. He had at least 2, 3 years into it. So he had a basic understanding of back-end development. So this was good for Alex. So he built the application using a basic client-server model, incorporating server-side logic with Node.js. How many here use Node.js? Okay, or we're using tools that use it under the cover. It's fun, it's cool, but hey. However, security was still not his top priority. So you can see what the construction was. But Alex's application, being sturdier than Sam's, like a house of sticks, it was stronger. But there were basic security measures such as input sanitization and simple authentication. Who here knows what I mean by input sanitization? Raise your hands. There's a few people. Okay, very important to know. We all know what authentication is, right? We have to log into something and it authenticates us. But do you know about authorization? Anyways, the wolf strikes again. The hacker then targeted Alex's application. Though it took a bit more effort, it was kind of fun for the hacker because it offered him up a challenge. The hacker found some vulnerabilities in the inadequate input validation and the weak authentication mechanisms. And the next thing you know, the house fell apart. So Alex and Sam went running over to their grandmother's house, somebody my age. That would have been Catherine. Catherine, who is older than me, I believe, by a few years. Okay. She's also more brilliant, mathematician. She's been in it a while. In her retired years, she's learning all these programming languages. So Catherine is a professional programmer, experienced software architect. She understood the importance of building secure applications from the ground up. She worked for NASA. Come on, what do you expect? All right. She chose using C#, ASP.NET Core, in .NET 8.0. Catherine focused on strong typing, secure coding practices, and thorough error handling. We all do our error handling, right? All right. So Catherine, she used all these tools. But she focused on a lot of things like security measures, data validation, secure code. There's a whole list of secure coding practices, error handling. She used code analysis, and she used SonarLint and SonarQube. I'll get to that in a little bit. She ran static scans, and she also had continuous integration. She had a full pipeline set up. Her application deployed automatically at the push of a button. So Catherine's application was like a house of bricks. It had robust security measures, which I just mentioned. She used the tools like SonarLint, burn that in your head, reused to scan for vulnerabilities and ensure that the application was as secure as possible. So when the wolf found this, he attempted to breach Catherine's application, but he met with all these defenses. He just could not do it. The strong validation and all the other security practices that she complied with thwarted any attempt at SQL injection or cross-site scripting. Hey, Catherine's house is where everybody ended up living, just like the three little pigs. Okay. You also, in the world of computers and web applications, who do you think was making the money after all that? All right. So the moral of the story of the three little programmers teaches us that building secure applications requires more than just the focus on speed and aesthetics. Burn that in your head, because when that manager's going, I need it done by this time and this here, you know there's going to be problems down the road. Because anything built fast and quick or just to be pretty doesn't cut it. Because when the makeup comes off, I'm not going any further than that. So novice programmers like Sam may create visually appealing applications quickly, but without security measures, they're vulnerable to attacks. A little redundant, but here I go. And average programmers like Alex, they may know a little about basic security, but without a comprehensive approach, emphasis on that comprehensive, their applications remain at risk. Security is an ongoing thing. Just because it was okay when we pushed it, that doesn't mean that 2 days from now, somebody hasn't come up with another way to attack. It is a professional programmers like Catherine who understand that the importance of secure coding practices and the use of the right tools and techniques, who build the applications that are the ones that can build applications that withstand attacks from even the most determined hackers. By focusing on security at the outset and continuously integrating security measures throughout the development process, we can build robust and secure applications that withstand the test of time. Remember, in the world of full stack development, it's not about building fast and pretty. It's about building strong and secure. So, what is hardcore development? I've got a list of slides here. You'll all get the slide deck later, but I'm going to go through the slides anyways. I'm not going to read them. Front end. Hey, if you really want to know, you could be a front end developer and always be a front end developer. And like my nephew, be making 140,000 a year, and he's mainly front end, though I've weaned him into the back end a little bit. But his job right now, it's 140K, and he's strictly front end. At the most part, he's doing pretty, but every now and then I get a call. Hey, how do I get around this? That's how that works. He uses more than HTML. He's using all the tools. I heard React about it around here. I haven't heard Vue around here in a while, but you have all these front end tools. Performance optimization on the front end, cross-browser compatibility, and we'll get started on browsers in a little bit. On the back end, you have server-side programming. You have Node.js for that, Java, C#, developing RESTful APIs and web services. That's your back end line draw. Okay, and I'll get towards that in a minute. Server management, there's all kind of things there. There's all kind of security, like security guidelines. We'll get to that in a minute. There's DevOps, version control, automation, monitoring and logging. There's all kind of things. And these lists on these pages are not complete, but it's probably more than many of you thought about. Soft skills for those younglings out there. And even for me, I'm still learning soft skills, and it's been too long. My wife's given up. But yes, you need to learn things like problem solving. Hey, I'm good at that. You need to learn about optimizing code. You need to learn collaboration. A lot of programmers like me, ADD, okay, that's perfect for programmers. When you're sitting there with 5 monitors going on and multiple screens, generally, if you can see someone doing that, they've got a touch ADD going on. However, you also got to learn how to control that, because you need to collaborate and play well with others. Okay. Continuously learning, very important. I've been in it since way back when, way before it was any of you or a gleam in anyone's eye. Like I said, I go back to, we can talk about that over drinks later. But yeah, bottom line, I go back. I'm learning Rust for the fun of it. I don't expect, I'm winding my career down. I could probably do another 10 years at the university, just doing what I'm doing there, and then I'll retire. So that should kind of date me a little bit there. But yeah, so I'm learning Rust for the fun of it, because Ronnie has a home lab. I've already had 3 servers go down, and I'm replacing them with mini PCs, and that's a whole other interesting conversation. Like I said, I've got a Xeon server that's still standing from 2010 in my office, chewing up electricity. And it's running Red Hat Linux on it, full version. I'm running Docker on it, all kind of goodies. I've already done stuff from my laptop, rolled it up in Docker using Visual Studio Code, and then popped it over, stood it up in Docker over there, had an Nginx running through it, the whole bit. That's the kind of stuff I play with for fun and all that kind of stuff. You also need to learn project management. Like I said, we got deadlines to meet, and you need to learn how to estimate. So other presentations I've done. Now, when we discuss back end, you're going to want to go see this. I did this, what, 3-4 years ago with you? So raise your hand, you know, restful. You're going to want to watch this, because in this, it's not just restful. You also get a history lesson, which seems to happen with me. But this here, I cover HATOS. How many here know what HATOS is? You don't know what the hypermedia as the engine of application state is? Well, then you're not a true web developer. All right, seriously, go watch this. The code is out there. It's done in C#, ASP.NET Core. It's strict, and it's actually used in this database, which is kind of the other reason I used it here. But it's RESTful API, the HATOS way. In there, you will get a little history. There's some embarrassing moments. I put my foot in my mouth a few times. Did you ever write that policy on behavior for people in the user group? I'm the inspiration for that. But yes, you're going to want to go watch this. Okay. It's worth a revisit. The code's there. I'm not sure I uplifted it to, I did this in .NET 5. I uplifted it to 6 here. I didn't uplift it to 8, but it doesn't matter. You'll be able to run that 6. 6 is a LTS version of .NET. Even numbers are always LTS now. That's the policy. So you'll go to that. Now let's get to the code. Let me kill this here. Please excuse any cough I may have. Let's do this. And we will kill that. All right. Shrink that down. Control, alternate Shift H to hide that. Huh? Is it still going? I didn't turn. Yeah, I just had to hide that. Okay, so we got that, we got that, we got that. And we want to go over to this one. Visual Studio Code. I actually started writing this app. My wife and I were driving to New Jersey when I started the app in Visual Studio Code in the car with a hotspot as I drove up 95 to New Jersey. My wife doesn't let me drive, so I took my computer and I played with this. I don't know why she doesn't let me drive, but you know, it is what it is. We have this here. Now, in here, I'm using various extensions that are designed the C# development kit that tries to make this work like Visual Studio, which I'm going to cover in a minute. It works. All you people who like Visual Studio Code, I've upped the sizes of the fonts so it looks a little more like it does here. But you see there's Solution Explorer, that's added. Here's your folder view that all of you who use Visual Studio Code know about. And actually, I have it in a workspace. What I want to show you here is that runs. Let me go to debug. I'm going to spin this up and take it well less. The reason I'm showing it here first is because everything I have to display on Visual Studio. And I'll elaborate on that as to why. I have various extensions loaded in here. And what happened is, open it up. Good. Projects on restore. All right, wait a minute. And wait for the pop-up to come. So you don't run it. So before I open the Windows terminal, it's a little slower. I get a little antsy. It's Visual Studio Code. Very nice product. And actually, they don't do Rust in Visual Studio yet. So when I play Rust, it's in Visual Studio Code. All right. So you see we're spit up. It's doing its thing. It's slowly doing a lot going on this laptop. And according to my notes, I've gotten ahead of myself. So once I do this, we're going to step back. Terminal will be reused by task pressing the key. Oh, here it is. It's spinning. So that took a while. It's still spinning up because I have all kind of monitoring and logging stuff. So we should see something in that window in a minute. Oh yeah, here we go. It's initiating the program.cs file, and it's going through, and you see it's still running in the background. The application is now almost up. Setting up SQL Server. Yeah, remember, I've got a lot of things running on this laptop right now. So I'm going to copy this. No, don't do that. I want to copy this. Now I'm just going to fire it off. So right now, in Studio Code or in Edge, pardon me. So what you see here is the basic application that we're going to go through the code for. Real quickly, hey, you can find a DVD. Nobody does DVDs anymore, I know. Okay. And that would be easier explained if I had not skipped over the steps we're going to backtrack on. And I'm going to stop there. I'm not going to go through that anymore. But as you can see, it works in Visual Studio Code. I am going to close Visual Studio Code because I want my resource laptop. And this is a 32 gig laptop i7. And it's nothing but an SSD for the drive. So now I've done that. What I forgot to show you was SSMS. How many here do database? All right, database people. Anyone who doesn't needs to learn it if you're going to be a true full stack developer. Now, there's all kinds of databases out there, but every tool I'm showing you is free from Microsoft. You get Visual Studio Code. You can download SQL Server Developer Edition, which is exactly equivalent to the Enterprise Edition, that if you tried to run it in a company would cost you buku bucks to stand up. I have one of those running on here right now, as you can see, with lots of databases on there, because I play with lots of stuff. And I should have used one of these other databases like AdventureWorks. Oh, I don't even have that loaded. There's the light version of AdventureWorks. I have multiple versions of AdventureWorks, which is a bicycle store that Microsoft puts out there, but it's written the database. If you're going to learn databases, you pull down the AdventureWorks database, you load SSMS, you install Visual SQL Server, and you start learning databases. And what I suggest to anyone starting out here, and we'll have all this information later. It'll all get posted. And actually, the RESTful thing has documents on how to download that software and how to sign up for free and all the tools you would need, how to install them, the whole bit. So make sure you get to that one. Right now, I have a collection of queries here. If I run this, this is going to run a ton of queries against the DVD store. I just did that real quick. And you can imagine looking at the data of the DVD store, and it's a business, or it's a light database of. This is a nice example of what a database could be. I use a tool. If you're going to get into databases, there's a tool. You can get the academic version of this. It's called DB Schema. In here, I designed the database in an ER diagram. I could do it all on paper here, and then give commands going into the database and build the database on the database server. This tool works with Oracle. It works with Postgres, it works with MySQL, MariaDB, and I could just go citing them down. So it's a nice little tool for anyone who's got serious interest in databases. I recommend grabbing this tool. It is a few bucks, but like I said, there's an academic version. If you got a student email, hey, you get the idea. All right. That's cool. What that also did was I took this here, and there's a ton of information. I have this ER diagram, right? I go click on this, films, and it brings up information about it. I could have, if I got this database, see the description column? Vicente has worked with me. Actually, Marcos, I don't know if he's online. One of the projects where we were at, I don't know if you were there when I started doing it, went back over one of the databases and started using this tool to go put descriptions in. You really should have descriptions of what that description column is, what that title column is, so on. What's the business use case around that? Let's think about it. There's more to building a database than you can imagine. And if I gave you this, right now, because there's no descriptions, you'd have to figure out, well, it's called film table, right? What are all these? Rental rate. Well, I know what that is, but what if they named it some RR for rental rate? Would be really horrible and a poorly designed database. But the nice part about that is, and if I can find it here, it's open here, you will see that I can generate documentation. This is an interactive HTML document. So I'm going to zoom in here real quick. And you see I hover over it. I got information. It tells me about these here. Tells me the linkage between other tables. See how that highlights? Film store ID goes over to the store table. Interesting. If I go clicking on that, it takes me out of the documentation all printed here, interactive. And this would have been really nice. It's really nice in the business because this is your data dictionary. Had this, when we converted the Scala database, which I'll show you in a minute, over and put descriptions in, that would have been really useful for a development team. Okay. Now, to get back to where I went off on the tangent, when I showed you the search engine, spin up there. Spin up, head back. Oops, we're the wrong place. All right, way back here. So here, if I go Sakala, did I spell it right? No, I always spell it wrong. Yeah, Sakila, I believe it is. Sakala database. What's that? Okay, for all you MySQL people out there, here's the Sakala database. Anything you would want to know about it, we just ported it over to SQL Server. The internet speeds are slow here. Sakala database. This goes into the painful detail that we probably should have transferred to my ER diagram. But you learn about this database, the structure, example usages. I'm just saying, if you want to learn databases, you start digging into what I've given you in the RESTful API thing, and this one here. If you're just starting out, you follow my examples of coding, and you're on the right road to becoming a professional programmer, because you need to learn all this stuff. Information is information. So we have that there, the Scala database. So that's my database talk. All right. Okay, let's say goodbye to the database stuff right now. I'm going to close DB schema, get more room on my computer. We're going to leave that open. And we're going to go over here. So here we are. This is Visual Studio. Same files loaded in it were loaded in the Visual Studio code. I have it organized the way I want. I have it using my favorite theme that there happens to be. It says, I believe in love is the name of the theme. I didn't write it, but I could change all kind of stuff real quick here on the fly. Visual Studio. As you can see, I like to play around with themes. See, I believe in a thing called love's what it's called, but I have other dark ones. I have light ones. Can everyone see these screens okay? All right, so we're going to leave it here. So how many here do unit testing? All right, we have a few people. So how many here, when you're writing a program, just start writing it and then you kind of just run it to test it? Yeah, well, that's how we all started. Okay. When I develop, I start with unit tests. I'll write my class, or I'll write my test and then write my class, which is a C# thing or a C thing or a Java thing and so on. I start writing that and then I write some tests around it for the most part. As you can tell, I only have 48 tests here. I'm going to hit run on this, and I'm doing it in Visual Studio because it'll be a little faster than Visual Studio Code, believe it or not. Because there's a lot, this app is also written to do a lot of parallel type things. Like I could be moving through looking at files while it's running these unit tests. So this is a hardcore. This is Visual Studio 2022 Community Edition. Anyone in this room can download it. It will do everything from C++, C, Python. It'll do Node. It does a whole bunch of languages. The only thing it doesn't do now is Rust at the moment. It doesn't do Haskell, but unless you're a hardcore academic, you're not going to be playing with Haskell anyways. Rust, on the other hand, we won't. That's something for drinks later. Okay, as you can see, everything's green. All those unit tests, if I expand it, are green. Now, I broke the first rule of test-driven development. This test class here is actually live against the database because, believe it or not, I break my own rules. So I had the database. I started building this up here. This is my DAL code. Anyone know what a DAL is? Raise your hand. Data access layer. This is the code I write for accessing the database. This is using EF Core, Entity Framework Core, as a ORM. I'm going to say it, Object Relational Mapper. Okay, that's what an ORM is. You probably heard people talk about it. Now you know what it stands for. But what's it do? Well, I write mine so everything is in a folder. All right, I have my models, I have my maps, and I have my context object. You go, what's that? Well, the models, if I look here and click on actor, if you look at actor, All right. And we start going through it. I'm gonna put it in another view here. I use a tool in here called CodeMade. And if I look here, let me make that a little bigger. Control Shift plus. All right, so it doesn't work it in that part, but hey, you get the idea. So actor ID, first name, last name, so on. Let's jump back to the database here. And let's go find us the actor table. First, I got to find the right, there it is, DVD store, actor table. We look here, and here's my columns. I have the actor ID, first name, and last updated. Well, that's pretty cool. Okay, there's some subtle changes between those naming. You see, I fixed it. First name is all combined, you know, and it's written in a proper type thing because I want my code to be readable. All right. So what's that mean? Well, that's my model. Then I have a thing called a map. If I go up here and look at the actor map, in here, this is the EF core code that describes the database table. Cool. Now, what I've done is database first development is a back-end thing. A lot of you who here knows what code first development is. All right. Code first development is you write the code and then it gets turned into the database. But if you're going to work professionally, odds are they already got the database. So now this allows me, there's stuff I can do to reverse engineer that to make this mapping code. So now I can write really nice, clean code the way I did that model. First names capitalized. I have a certain naming convention versus the craziness that is actor ID all lowercase, first name all lowercase, and so on. So this is the kind of thought you go into. How do I get the database stuff into the application? And that's what this code is about. We have my mapping that maps everything from the database to these models. Okay, well, that's cool. Then we have a DB context. The DB context pulls everything together because an actor is one entity, one row in a column. But you have a table with all these columns, and that's where we get what's called a DB set. So we create in our context, we now refer to our table as actors because it's a table full of actors, right? Okay, so, and that's what all this code is doing. That doesn't look that hard. Once you understand the concepts, that code's rather simple. You could do that, right? Once you understood what you were trying to accomplish. And that's one of the points I want to get across. Before I go any further, everything is a concept. Everything we're doing now, everything they'll do in the future, stuff they're doing with AI, believe it or not, all goes back to stuff we've all talked about a couple decades ago. All right. Okay. We all talked about it. I used a language called Prolog. That was one of our first tools in attempt at artificial intelligence. Everything that goes on in the tools you're using, everything that goes on deep underneath was written with the older tools. Who here, raise your hand. No, don't raise your hand. What's your favorite browser?
Chrome. Firefox.
Firefox, yeah. All right. Anyone use Brave? All right. Well, DuckDuckGo is a search. Well, yeah. Yeah. All right. So how many here think JavaScript is what the browser's written in? No. So remember, something came before whatever you're using. I started in assembly code. I was on the hardware side. In the early days, we made the hardware, then we had to figure out how to make it work. And that led to software. Okay. DOS. Who here doesn't know what DOS means? Raise your hand. All right. DOS. You know what DOS means. DOS means disk operating system. Well, what's it? Well, we got code here. People learn how to do stuff on the computer. We got the CPU working. Well, what happens when you turn the computer off? Well, that didn't last long. I'm not going to retype that in just to use the program. We needed to record it somewhere. We had to record it. We ended up writing it to tape. And then, well, actually, yeah, never mind. We wrote it to tape. Then we wrote it to disks. I had a TRS-80, one of the first computers like that, 8-inch floppy drives. Go look that up on Wikipedia, what an 8-inch floppy drive looks. And you talk about fragile. We're talking about a disk in a computer that had maybe 8K of RAM, 8 kilobytes of RAM, not megabits. Yes. Yes. Well, yeah, and that's not even the current floppy disk. That was a 3.5-inch disk is what the save button looks like now. And that's just an icon. And that was a really, those were cool because we could throw them around the room and the data would stay pretty safe. We used to have floppy disk fights, stuff like that in the office. But hey, when things got boring, we had, before there were Nerf guns, floppy disks got thrown around the room. Let's put it that way. All right. So that's the kind of stuff you need to learn, because underneath, your browsers are written using C and C++. Okay. C was a system programming language. I started in assembler. If you've ever looked at assembler, it's scary. I never want to go there again. But I learned C. And then I started writing things to RS-232 ports for medical equipment. Crazy stuff like that. Not attack systems on planes, or avionics. But everything starts with what came before it. Python. Who's the Python people in here? All right. What's Python written in? It's written in C, not C++. Python's written in C because Python's a little bit older. And they had C, so that's what they wrote it in. Your operating systems were written in C and assembler. And then they moved it all into C. Microsoft, Linux, all of those. You have is it GCC? Is it generally, depending on your Linux distro, you go looking for, or you have to add the package for, I believe it's GCC and all. You just add in everything for C development and you're there. Okay. All those little how many here do Linux? Okay. How many have gone to the DOS prompt on Windows? Okay. All those little programs, dir, that's a little program. Okay. It's a little program written in C that you could do right here with this and Visual Studio Code will write in C. Okay. So that's what I'm getting towards. Everything you need to do, you need to learn the concepts, because underneath that big database SQL Server, Oracle, how many use Oracle? I was also an OCP, Oracle Certified Professional, years and years ago. Okay, MySQL, Oracle bought them and is in the process of killing them slowly. All right, all that stuff's written in C. Actually, originally in Pro C it was called. Okay, then eventually Oracle stuck the Java runtime inside Oracle. But in earlier days, when they were DOS, don't get me started there. Once it came into a really good Oracle server, they were writing, I used to write C modules inside my Oracle to do things like crunch a number a certain way and things like that. All that stuff is still there. You download Postgres, all that stuff. It's there. That's what it's built on, and you can get at it. Take us to security now. Security. Well, there was problems. Got to remember, this stuff is old. How come Microsoft got attacked so much? Anybody know the reason? Because it was the most popular. We don't rob from the little guy down the street when the banks got more money, right? Okay. However, when we started in C, there was a thing called the standard IO library. Standard IO, simple code. simply had a bunch of errors in it. It was vulnerable. And that actually, I'm simplifying it. That actually led to most of the serious problems that nailed Microsoft in the early days and stuff like that. Meanwhile, Sun was using that over as they ported stuff to different things. They went and fixed a lot of the stuff in their versions of the operating system. And it was the back and forth. Well, Linux is safer, yada, yada, yada. Well, that's because Microsoft is busy trying to make money and everything, and they're trying to play catch up. These guys, all they were over there was doing, but don't get me started. But that's the kind of thing. We're talking security. Now, I got this here. Part of this here in the micro ORM helps with security. It's mapping, it's validating. If I go back to these models, I'm using a thing called data annotations. So let's go to films. Yes. Sun, yeah, they all had major breaches. There's actually a couple I follow as much as I can. There's been some actual serious breaches going on all over the place. It's not just Sun. The latest one was, I sent this out yesterday too. There's a lot. That's a whole nother area. I try to keep up on everything, but yes, there are breaches everywhere. There's stuff, and that's just the stuff that gets reported. And a lot of that stuff, when it gets reported, was like a year ago, stuff like that. But staying back, data validation. So at this level in the micro ORM, you see this code here above it, the markup where it says film ID, display name. Okay, let's scroll down a little further. I didn't pick a good one, but hey. So yeah, well, it's like I said, this model, if I had gone further, you see that release year, I would have labeled that release year a little differently. But as you can see here, it says max length, string length, display name. All that stuff can get used at various levels to validate that. So if a string can be really big. And what if I was doing something to do SQL injection? All right. And that's a whole security thing, but I have tons of ways to attack a database or attack an application. I can put in SQL injection where depending how badly the app is written, it could return stuff back to my web screen, either in an error or back on the screen itself to tell me about the database. Well, because I have this max validation of 4, if I tried to load code into that, the micro ORM is going to say, hey, nah, you're only allowed 4 characters, not 25 words that equal some database query. So that's just validation at one level. This is at the ORM code. You want to do data validation at all the other levels. Who can guess how many levels? Take a shot. If you're going to a website and you're typing in your first name, last name, okay, how many times do you think that should be validated? Just in the browser, right? No. Yeah, at least 3 times. You want it to be validated in the browser, but then it's got to go across the wire. It's going to go across the wire to the API or the body of the code like we're getting to up here. And when it comes into there, it needs to be checked as soon as it gets there. Then it's going to get back and get checked to the database. Actually, there's 4 levels if you're going to do it right. You need to do it at the front end too. And I'll explain why in a minute. Is Marcos on there? Is he listed? Okay. All right. If Marcos is on there, he worked with Vicente and I. Okay. Marcos did a lot of things with a tool called Fluent Validation. It's a .NET open source tool. I use it too. You can use it for validation, or you can take it to the level of business rules if you get really creative. All right. So imagine it comes from the web browser, goes through the wire, and all right, tell them good. So it comes through the wire. Now there's all these cool tools like Wireshark, I'm running Kali Linux in my lab in a very closed network because that stuff's dangerous. Okay. But it hits that API, let's say. API checks it and lets it in. Then you should have another layer of validation. Like I'm saying with fluent validation, it scrutinizes the data a little more. Maybe it needs certain business rules. Excuse me, maybe it needs to be formatted a certain way. So you have it there, and then you also have it where it goes back into the database. So you could end up with anywhere from 3 to 5 layers of checks just on the data. That's all I'm talking about. Because if we look here, I have this film, right? Now let's get up to the website. That was just my DAL code, but my DAL code gets called by my MVC code. And before I get too crazy, staying on the data validation. See the film catalog here? If I go in here under models, I have film view model. And if you look in here, I didn't get overly creative, but look, see the film ID here versus the film ID here is different. Okay. So this film ID, actually, this is the model I'm using to get the data to the front end and back, to the web browser and back. I'm using this model to represent the data and goes to the browser. Now, the same data annotation I have here in the Microsoft world and the tools I have here, the data annotation will work, and I'm going to show you in a minute. Excuse me. It validates the front end. So I don't have to get too crazy evaluating everything on the front end because it's going to work with jQuery and the tools I'm going to show here to do the validation. So put that off to the side. Let me show you this structure. Now, this is a Microsoft design where I'm doing what's called an MVC. And for those of us who know design patterns, yes, Crystal? How many? 5 minutes. Oh, okay.
Probably, like if you want to have special questions.
Yeah, or do we need to do part 2? All right, let's get the important stuff. This here's data structure, MVC, model view controller pattern. If you don't know it, go look it up. Start looking, if you're new to it, look at design patterns. I got a whole thing I did on design patterns, 6 years ago or something like that. If you look here at my structure, here's my web root. Guess what's in there? All my libraries. See, I'm using jQuery validation, all that kind of stuff. All these kind of goodies here. I haven't even got to the important stuff yet. I knew this was too much. I have a section called areas, common, controllers, migrations, models, views. Okay, controllers, models, view. That's the first top layer of the program. But we're talking large scale application. If Vicente, Marcos, and 5 other people are working on this big application for a store, I'm designing this where Vicente might work on the film catalog. I'm working on the identity and security stuff. And a couple other people are working on the store section. Okay. And then there might be another thing for back-end financials, things like that. But because I've set this up the way it is, if you look at each one of these areas, I also have in there common code, controllers, models, repositories. That's another design pattern, and views. Okay, in there, I can get really crazy, and you can have multiple controllers working in here and multiple people working in here, where Vicente might be working on film catalog, Zarella might be working on another thing to do with films, like customers or whatever, different things like actors that go in the films, things like that. You can get really crazy, but it encapsulates everything so that they don't walk on one another. We can all be having our own branch in GitHub. They make push requests to put it back into GitHub, and we build the application as a team. That's what enterprise development's about. Large scale applications, divide up the work, have a design, and you go from there. Security, we ain't even touching on the tools here. Do you want to do another one of these? Did you get one for July or whatever? Yeah. Because I could pick up where we left off, but everyone will get at this code. You'll get at this to go, because there are tools I'm using here. If we look up here under analyze, I'm going to engage, run an analysis on the solution. And this is going to use the code analyzer of the Roslyn compiler that's used for C#. And it uses sonar lint. Who here knows what a lint is? Or linter is? Okay. A linter, I don't care what language you're in, make sure you have the linter for it. Because the linter is going to say, you know, the way you wrote this, you might want to reconsider writing it this way. Okay. And I'm going to go here real quick. So Sonar Cube, if I go over here to the error list, I'm jumping ahead. See these? See this S101? It's suggesting I rename something, and I have to get around that. But I'm going to jump over here because I put bad code in here intentionally under common. Down here, induce problems, problematic code. All right. And it'll find errors in a minute. I have to run a scan. Let's open this file here. JavaScript. I threw some bad JavaScript stuff in here. All right. Let's run the scan on that. Of course, my laptop's probably in the middle of choking and it won't scan. Yeah, so it's moving. You see it running up the count now. So right now, Visual Studio, these scanners are running, and look, it's finding all these warnings. All right. So I'm going to close this down here. And if we look here and I sort by file, it's finding all this stuff that it wants me to look at and say, you might be doing this wrong. See these little S's? That's coming from Sonar Lint, which does security analysis. All right. Let's go further down here. So it's finding stuff that you should look at and address and decide whether you need to fix it or not based on your skill level or somebody else's skill level. So if you look under here, JavaScript, where to go? I just saw Java, sort by type. That would be the easier way to do it. And I'm in here, select current file. That'll weed that out. So right now, this is pointing out errors in my JavaScript. All right. So if I click on that, let me drag this down here. Click on this. So if I click on this guy here, let's grab this one. This is common. How many here use var in their JavaScript? Yeah, I saw a hand go up. All right. var. Okay, that's cool. It's common. I learned it. I still use var in C#, but it doesn't have the same ramifications. So if I click on this here, where to go? This opens up Sonar rule help. Okay, you go into the rule help here. It says, why is this an issue? It's going to tell you why it's an issue, because in ECMAScript 6, which is the standard for JavaScript, it explains to you. So you're going to learn, like, why is the compiler or why is the linter telling me? This was one of the main points. I'm trying to get it out now. In your linter, in this case, Sonar Lint, you know, it's not even hooked up to a Sonar Cube. That's a whole nother story. It's to sit here and say, hey, you might want to reconsider doing this, and here's why. And it goes through and it talks about it. You're like, okay, well, that's good. You told me about it. How about more info? Okay. And it goes through and explains it. Depending on the error, it will go to the point of, let me go here. So the rules, here we go. Find that. Yes, that was my point. Every tool I'm using Visual Studio Code part is in Visual Studio. Visual Studio Code is in Visual Studio. But it's more robust, the tooling. Okay, if you go here to the Sonar Lint rules, look at the languages. C#, plus, you go down here, you'll see JavaScript. JavaScript, and Java, all that. You need to do that. So you go to C#, but you're going to want to do this for whatever your language is. Well, here's some rules we should look at. Vulnerabilities. It's going to point you to these rules. And depending on the case, if we look under vulnerabilities, or let's find bugs. Let's just take one in bugs. All right. Any one of bugs. Regular expressions. Should be statically done. All right. System low on resources. Yeah, I know. Here, what's the issue? It teaches you the issue. Same thing was showing you that. But how can I fix it? It walks you through what's non-compliant and what's compliant. I've learned so much from a learner through the years, because I don't sit in the classroom very well. I have ADD, remember? But I can sit in front of 15 monitors or 5 monitors and 15 screens open on each one and know where everything is. Okay, so you go through that. Let's go back to the application real quick. I'm going to run it. Sorry about cough, people. I'm running it here and it'll be faster. I wanted to show you there's other things in this code. This is a full working code. It has authentication and authorization. Okay. It's one thing to authenticate. It's another thing to be authorized to use it. Okay. All right. So I'm going to log in here. All the code for this is here, which is stuff. One of these sections of this code could be one of these sessions. That's how big it is. So if I sign in here, admin example, right? I can go in here, go to user administration, because I'm the administrator, right? I go in here and spin it, and it's going to look at the authorization database, which is tied to the it's also the authentication in this case. I use the same library of tools interface with Active Directory at the university. So the Active Directory authenticates the person as, yeah, he's allowed to be here. Tell me the service groups I need. And then from there, I can do this. So let's go to manager. Manager example. Well, manager example is listed as manager. It has a role. This is role-based that I've set up. There's administrator. There's user. All right, we go back to the list. All right, let's do this. We'll log out just to prove my point. Remember the administration list was there? So now I'm going to log in again. If I click the right button, hang there. And let's change this to manager. All right, and the password, keep it. I got to type it in. Yes. One, 2, 3 pound, I believe is what it is. And I left the A out, manager. Nobody said I could type. All right. Now I got to type the password in again. And shift that. All right. Yes, save that. Look, it has find a DVD. It has film catalog. It doesn't have administration there. Well, how does it know that? You might have to write a lot of code for that, but let's go take a look real quick. I want to, just so I round out this part of the security side. So now I'm going to go back here in the code and film catalog. We go to the controller. I can manage security as granularly as I want. If we look here, I have special macros for film catalog, routing. That routing is a whole nother thing. But look, I authorize the role manager. So now the find a DVD section or store is public. I don't have any of that on that. So whenever anyone goes to the website, we don't want to stop anyone from going to the store, right? We would if I had a card in there, we would have a little something there, make them sign up or whatever. But we don't want them to get at the management. We don't want them to get at the administration. And I sure as heck don't want my manager getting at the administration stuff. And that's why you saw administration and all that. So I can control, if I'm going to go fire my manager and hire Zarella to take his place, I would go in there and switch him off so he only could do the public stuff. And then call him in the office. I'm just saying, that's how this stuff works in the real world. So all of that's in this code. And because I'm a programmer with OCD and everything, you'll notice in my code, I comment the heck out of everything. Control ML. I have comments on everything through the code. I have a description, which kind of ties to this. If I go to this tool here and I hover over each one of these things, see the little description, tells what it is. I can click on it, takes me to it. I go down here, delete, confirm, takes me to it. But if you look in the code, you know, I like to do a thing called pseudocode, like what do I want to do in comments? And then I start writing the code around it. So I'm partway there of describing how my code works. What you didn't notice in this application while it's running, let's go back here. The kind of stuff you'll find here is, look at this. I'm going to go to the last thing in the list. Did I go last? Yeah, there we go. All these different pages. I'm set up for 10 items on a page. I can jump around. I use search. Dino, I think, is one of them. Yeah, there's Dino. Dino. If I do the search, it searches code. Oh, there's only 3 things with Dino in it. So I've got searching in here. What's cool about it, that's fast, right? Well, if all that searching takes place on the back end, not the front end. Because if you were searching on the front end, you'd have had to pull all that information forward, search it there, which would take forever in the browser. And it's only got one event loop running in the browser. Whereas here, I can use the full power of the server, go through and say, hey, you told me I got X amount of records, yada, that's all in here. How to do that. And I'm using an open source tool that I use for all my stuff to do these very little pretty things. To do this, all this here, as you see, you get through it. And click these are all pretty quick. And when it's on real server, not my laptop, it's really fast. Okay, but you get the idea. See how that does it? Makes those little spaces. All that's in here. Go study the heck out of it. We'll make these links available. If we decide that you need to do a second half or focus on certain sections, this was something I'd suggested in the early days. Before COVID hit, we doing, what do we call them? The little sessions, huh? Code collabs. Originally, I was saying, just an idea. Hey, we do database code collab, design a database for Southwest Florida coders, except you're not standing up a website, right? Oh, well, we could redo the website with a proper database. Yeah. Yeah. But I'm saying during a code collab, we could do like, hey, this is how we designed the database. We do some sessions on that. Everybody go builds one or something. We start out. That was an idea I had. I'd like to revisit it. It would probably get me going back to regular, because the only way I remember this stuff is by doing it. Because and I start learning Rust, I'm going to start forgetting something. But yeah, but you get the general idea. There's a lot to learn. There's a lot of concepts. Don't let it scare you. You guys got better memory than I have. I've killed a few brain cells, might kill a few more after this at the Patio de Leon. But yes, you get the idea. So all you kids should be better than me. And by kids, I mean even you. You know, I won't hold it against you with the Air Force. I tried to transfer over. I was Marine Air Wing. So yeah. So yeah. But that's where I'm at. Is there any questions? Because I'm sure there's plenty. Or did I fry everybody's brain? Did I raise your hand if I scared the heck out of you and you never want to go near this again? All right. C#. I usually look at the younger ones in the back. Do you want to do it because you want to write games? Yeah. Good. Don't. It's a very competitive field. You will need to know C#. C# is used in more games than you can imagine, because oh man, I can't even remember how to say his name, and I know him. I'm bad with names, by the way. So the gentleman who did it wrote what was called Mono. He wrote his own light version of C# or .NET is what it was. He did that. People started picking that up and using that for a lot of the gaming. I'm talking, well, C# was 2005. Well, call it 2005. It was more than that, but let's call 2005. And all that stuff went into play. Then that's what led to things like Unity and stuff like that. I am not a game developer. I'm forbidden near games because of a thing called computer Williams syndrome from years ago. So you can imagine what that's all about. But yeah, that's how it works. Like I said, this is just too much. Go ahead. Uh-huh. Ah. Okay, he was in the Marines. My primary MOS was 4641, combat photographer. Now, keep in mind, I also had 0211 and 0241. 0211's human intel. And the other one was image analysis specialist, but in my day, it was imagery interpreter. Those were my intelligence MOSs. I had a 2862, which is basic electronics technician. And you're only allowed 3 MOSs at a time. But my other one was 2855. And that is, there were 2 names for it. One of it was TERPS, but it's intelligence related electronic stuff. Okay. I'm part of the team that took the MiG-25 apart in 1976 in Japan. I was one of 2 combat photographers that photographed every nut and bolt that came out of that when they took it apart. And I was also one of the first people on the scene. We were headed to Korea when we got the message, and we ended up in northern Japan. And I was one of the first Americans on site. And because I was there, and because the unit I was in was a joint military intelligence unit, it studied Soviet technology, which was why I was there in the first place. So yeah, I got all kind of cool, weird stories. I tried to stay in Japan and they sent me home. 2 weeks later, I was teaching photography. What was that? Okay, personally, I believe in strong type languages. You learn to code in strong type, you can do anything. Java, C, C#, Rust would be a really good one to start on, because they're going to use Rust to replace all the bad stuff written in C#, which means at some point browsers will probably be written with Rust if they're smart, because it's performant. There's a whole lot of reasons around it. The other thing is if you're going to stay on the browser side, you're still going to need to learn strong type language if you want to get really good, because of WASM, which is known as WebAssembly. It seems these people, since the world loves the browser has become its own little virtual machine. Raise your hand. How many know that there's a database inside your browser? Right. There's so much put into the browser now, it's not even funny. Okay, but if you look at it, the construction of a browser, it's just a virtual machine. That's what they're turning it into. It's not a virtual machine, but conceptually it is. And now you want to, so because Google wants to keep you in Chrome. Everybody wants, that's why they had the browser wars, because most people, all they know how to use is a browser. Phone apps are not that complicated. If you look at any phone app, look at what it does compared to a real application. Phone apps are simple. The only thing that's a pain about them is there's so many different types of phones and the screens are all different, things like that. And the operating system changes every what? How often they update a phone operating system? Need I say more? And they were yelling at Microsoft. Because you have all these updates to Windows. Yeah, right. Look at how many times your browser gets updated. Stuff like that. But I'm down a rabbit hole. Here we go. But that's enough. Okay, I didn't get through everything. I'm sorry, but I knew that was going to happen. And it's time to get medicated. Go ahead.
You can hear me. For our friends online, we're gonna close the session now. So thank you for joining. If you're on Slack or anything, or even on the Meetup page, I will post a video probably this weekend. And thank you for joining us. And for the ones that are here, if this is your first time here, usually we have this tradition that we like to go. It's not rain. I don't think it's gonna rain anymore, right?
I don't think so either.
We usually have this tradition that we like to go to downtown House of Pizza, which is just a few blocks, probably like 4 blocks walking. Even if you car here, Ron is going to be there. So if you have more questions for here and you want to talk to him.
Disclaimer, I will be there. But Vicente and I got to stop at 10:25 because I need an old fashioned to medicate my sinus condition going on in the back of my throat. No, old fashioned.
We usually sit there. When it's around. If it's wet, just so you know, if it's wet, we're probably going to sit inside. But we are going to be doing them with the building very soon. So we're just going to be here maybe for 5 minutes while we pack up and then we leave. But thank you everyone for joining me.
How do I close Zoom? I don't do Zoom. Show meeting. Oh, there it is.
Share, just do this stop share.
Stop sharing. There
You
it
can
is.
just leave. I'm gonna end it here.
All right.